problems with 802.11n. See, we saw a lot of advantages of .11n, which helps us increase the throughput. And by the way, the throughput can go all the way up to 600 Mbps. I'll talk about that here. The throughput in .11, the data rate, sorry, not throughput, guys. The data rate in .11n, I'll just change this here as well, so it's not confusing. The data rate can go all the way up to 600 Mbps on 40 megahertz. In .11a, we had up to 54. In .11b, we had up to 11 Mbps, but in .11n, we have 600 Mbps on 40 megahertz. Okay, this is the advantage of .11n, and then all those factors which we discussed in the last video, all the advantages, they contribute in taking the throughput or data rate to 600 Mbps. Okay, anyway, coming back to the problems with .11n, we know that .11n has been a major success in the Wi-Fi world. It took throughput from 54 to 600, but there are some issues with .11n as well. We will discuss about that. The first and the foremost is that .11n is very erratic, which means if you remember that in .11n we do echo cancellation, which is taking advantage of multipath. Now it is highly possible that a client sitting on the ground and connecting to an AP right here is taking full advantage of multipath and getting great throughput. The moment the client moves here, the multipath, it might become difficult for this transmission to take advantage of multipath anymore, which means the throughput might drastically drop. Okay, so with slight movement of the client, it gets really erratic. The throughput can vary drastically. It might be on, let's say, a data rate of 300 Mbps. It might drop all the way to 150 Mbps. You never know. That's how drastic it is, because the slight change in the movement of the client can cause a high drop in the data rate. That's the problem with .11n. The second issue is that .11n is lossy. You can lose a lot of data, which simply means that if you are sending AMPDUs or AMSDUs, and if the network is not clean, if the network has some interference in it, right, MSDUs. Now one AMPDU lost, or while it is being transmitted, one big AMSDU is being transmitted, some interference happens here, the entire AMSDU is lost, which means the aggregation has to happen once again, and then you have to make sure that it is sent properly, or we can do fragmentation. But anyway, if you're doing aggregated MSDUs, then we are actually moving past fragmentation. We don't want to do that then. So in an environment which is not very RF friendly, you may lose a lot of data. Similarly, if from the AP to the client there is some communication happening, and from the AP to the client there is an AMPDU or MSDU which is sent, the client received it just fine, but while sending the block ACK, he faced some interference, which means the block ACK never reached the AP. The AP will assume that since I did not receive the acknowledgement, my data did not even reach the client. So again, the data has to be transmitted once again. Now, this is the problem with .11n, because it gets lossy sometimes, and this has been a concern, with .11n. I just wanted to also tell you that in aggregation of frames, which I missed in the last video, in aggregation of frames, the frames that are aggregated, that are combined together, they all have to be of the same 802.11e class, which means the QoS class of these frames have to be same. It cannot be that one is of voice, all of them have to be of voice. It cannot be that one is of voice, one is of data. That's not going to work. You cannot combine voice and data, you cannot combine these two in aggregation of frames. It has to be of the same class of QoS. Okay, cool. I think we have pretty much covered everything in .11n, and these are some of the advantages and disadvantages of .11n, and that's what makes this protocol really really great. But before I close this, I just want to say that as wireless guys, we have been always greedy. So even though we got up to 600 Mbps, we wanted more, and that gave rise to .11 AC protocol, which we will talk about in the next video. Thank you.